What do we get? I'll put a diagram. Okay, the liquid will rise. So here the meniscus should be like this. Next, the meniscus here. Some angle of contact also is being shown. Let me draw the liquid inside. He's asking what force you should apply on the tube to hold it vertically. See, capillary tube on its own cannot stay in the liquid. No, what is a capillary tube made up of glass? Glass, will it float in water? Not possible, no. So till now, what we are doing is some sort of like a on paper. Nowhere in the real world, what when you are supposed to hold it, there should be some stand or a person should hold. Person should hold it. So what force, what happened? He should apply to hold that particular capillary tube. That's what the question. Fine, able to understand now? Okay, there's a container. Let me. Now, what are the forces here? Force due to sufficiency should balance here. F dash, I'll write only F dash. And this is theta, angle of contact. Here also, the liquid will exert force, no? The water outside. This, I think I'll show F dash like this. Tell me like, what are these F dash? Force exerted by liquid on the capillary tube. By capillary tube on the liquid will be in this direction. I think I'm not bothered on the on the liquid. I'm bothered about on the capillary tube. So what are these forces? So this meniscus will exert force on the capillary tube here. Here the liquid outside the, which is present outside, will exert force. So we'll do one thing, F double dash, we'll write it symbol. And what is F dash? Force exerted by meniscus on tube. F double dash, force exerted by liquid in the vessel. Okay, fine. This is, so we are not bothered on the meniscus. Now on the capillary tube is needed. Then weight of this tube will act. So how much of external force I should apply? I should apply external force. So what is the radius of the capillary tube? Let it be R. Any simplification. So here I think the meniscus should be brought it here. This should be theta. Capital R is meniscus, small r is radius of capillary tube. So what is the cos theta? Wall is 30 degrees is telling. Okay, we'll agree this diagram. This is theta 90 minus theta. So what about this? This is the normal to meniscus. This is the tangential to meniscus. I think by this time you know it. So therefore this should be the theta. So cos theta equal to smaller by capital. Theta is angle of contact. Now, what should be the force now? It is in contact with the radius of meniscus or with this particular thing. Radius of meniscus has to be come into picture, no? Okay, let's write the forces now. F external equal to mg plus force due to surface tension. Surface tension into 2 pi r cos theta. Fine. Plus surface tension into here also the same thing. So 2 pi r cos theta. What is r cos theta? Should be small r. So mg into plus 4 pi. Okay, we'll agree this. Why r cos theta? Why this is the force, its component. Fine. So these are the some conditions are there. Let's take the next one. Oh, yeah. Read the question. This is a liquid. Read the question. I'll give some 2-3 minutes time to analyze this. Just some. I think I'm. What is the radius of the tube? Smaller, no? So some correction is there. So I think the symbols is the problem. Huh? Smaller. They should be. Just make correction. Huh? This is something I think I'll be giving wrong information. This not needed. All not needed. Because what is the force due to surface? Radius of the capillary tube is this one. Smaller. Only this much you write it. Huh? 4 pi st r cos theta. This should be the thing, huh? No, this capital R, you need not to bother. Just leave this, not at all. So because what is the radius of capillary tube? You see that one. So I think what is where the force should be acting like this. Huh? I think I'll give diagram and I'll explain. It'll be a better idea. So what is the radius of go back to capillary rise and fall? You can see there. This is R. This R, no. This will be the capital R. This will be the small r. And this is the angle of contact. Okay, fine, everything. But the force, what happened? Where do it act? It will act at the edge. It will be acting at the edge. So that the force due to suffocation will be acting at the edge. No, here it should be. F dash, where we used to take like this. So now, what is the force due to suffocation? St into 2 pi r component of that. I think this is what we took that one. I think that's smaller capital R. Little bit be careful. If you want to replace smaller, okay, you can bring the formula. But anyway, like a radius of meniscus all not needed, theta directly given, radius of capillary tube is given, and angle of contact is given. Why we need radius of meniscus? So the answer, it should be like this. Huh? So what is the force due to suffocation should be 2 pi small r into cos 2 pi st into 2 pi r cos theta. I think capillary rise in the first problem, there's a method is what I do this diagram.